Well, good day, everybody. It's a real pleasure here to be in front of you, even though this is a virtual recording. I do appreciate the invite here through BC Geophysical Society to be a part of your workshop, Drones and Geoscience. A little introduction myself. My name is Steve Donovan. I'm here as the operations manager, the foremost UES test range in Southeast Alberta. One of two test ranges here in Canada. Again, very excited to be a part of this, especially this growing, emerging technology when we talk about the drones, not only in Canada, but also globally. It's the fastest growing technology pretty much here as you can fathom. If you could utilize it, drones could be definitely a part of it. So without any further ado, let's get into my presentation here. And just bear with me here as I go to it. Okay, BVLOS Innovation or BVLOS Inc. So we're going to be talking about the relationship here between BVLOS Inc. and the foremost UES test range. You're looking at an overview of VLOS to EVLOS and BVLOS, so lots of acronyms. It's visual line of sight, extended visual line of sight, and beyond visual line of sight. We're going to be looking at the differences between VLOS and BVLOS, BVLOS applications, and the VLOS to BVLOS protocols, challenges, and solutions. I have an introduction to BVLOS Inc. and foremost UES test range. So we're going to be looking here throughout this presentation is like anything else, terminology, acronyms. So there's going to be a vast number of acronyms. So this is just a quick overview without looking to go over them all as I go through this presentation here today with you. So first off, let's look at the relationship of BVLOS Innovation Center or BVLOS Inc. and the foremost UES test range. BVLOS Inc. is a private public partnership relationship, or a P3, with the Village of Foremost and UXS Consulting, who I work under. And the foremost UES test range user agency is the Village of Foremost, and it's managed and operated by UXS with restricted airspace for drones for research and development and test evaluation. So looking at June 1st, 2019, Transport Canada came out with the RPAS regulations, or Remote Piloting Aircraft System, and specifically they honed in on the VLOS, visual line of sight, between 250 gram and 25 kilogram. Those type of UAVs, registrations required. It's either going to be for recreational or commercial, and these are also going to be pretty much the classification that most of you folks are going to be operating under. Pilot exam, depending on your operations, either going to be basic or advanced. For the basic, age 14, and for advanced, age 16. Pilot certification required. Looking at that, you need to be certified by Transport Canada for either basic or advanced. And again, there's going to be two categories, and I'll go more in depth with them on the slides following. So the big part is to read and follow Transport Canada Canadian Air Regulations Part 9 for the RPAS section. A lot of information, and again, predominantly it's going to be in the VLOS, but they're also going to talk about how to apply and start looking at if you go to advanced and beyond visual line of sight. And to do anything for advanced, you're going to need what's called a Special Flight Operating Certificate or an SFOC in order to operate. This one here just shows different categories, a nice little poster from Transport Canada. So if you take a look here, if you're going to fly above 30 meters or 100 feet from bystanders, you can fly basic, and as long as you're under 400 feet above ground level, and uncontrolled airspace. So that's like 85% of rural BC, or where you don't have any urban centers, you don't have any airports, prisons, parks, anything like that. You can fly with your basic operation visual line of sight. Then for advanced operation, if you're looking at like a parade, flying over spectators, bystanders, under 30 meters. And if you're controlled airspace, like where there's air traffic control, you're going to need your advanced operation. And if it's going to be an advertised event like a parade, and if it's a drone over 25 kilogram, and if it's over 400 feet or extended range beyond the 750 meters, you're going to need an advanced certificate plus your special flight operating or your SFOC to operate. So visual line of sight, as I mentioned, it's roughly, if you're looking at between 750 meter, as far as the naked eye can see, 400 feet above ground level ceiling. Beyond visual line of sight is long and linear and encompasses a large area. Three classifications of drones. So if you're under 250 gram, like the DJI Mini 2, and now the 3's coming out, that's 249 grams. You don't need to have basic and or advanced. You just follow the normal rules of flying a drone. Should, you know, if you look at respect aspect, don't fly over people's neighbors' yards, fly away from controlled areas, don't be near them. And again, you should be flying within the visual line of sight and up to 400 feet. 250 to 25 kilograms, that's the Part 9, specifically visual line of sight. Again, the age there, you only need to be 14 for basic. Advanced is 16, as I mentioned before. And if you're going to be flying beyond visual line of sight, that's a special flight operating certificate. And anything over 25 kilogram is going to require an SFOC to fly. If we look over here, this is basically a picture showing a pilot and a command, or a PIC. So there's his visual range, operating range, as long as the eyesight out there for the PIC. Maximum height 400 feet. Now you can extend that if you have a visual observer or a VO, and they can keep extending that out, and those are called EVLOS, extended visual line of sight. Then once you go beyond VOs, then you're into the territory called beyond visual line of sight, and that is where you're definitely going to be needing an SFOC through Transport Canada to operate. So breaking it up, you know, for different applications, for the VLOS, well, you could look at it as hobbyists, sports, real estate, cinematography. Then in between here, we could be looking at structural inspection, surveying, mapping, environmental research, a lot of the GIC you'd be looking at for you folks, or GIS, I should say, first responders. And then the BVLOS, now you're extending range out, search and rescue, package delivery like drone delivery, linear inspections such as rail, oil, power lines, fish and game, and border patrol. And any of this for BVLOS, you're going to need that SFOC in order to operate. So Transport Canada, looking at the registration since April 29th, 2022, has published that there has been just almost 68,000 drones registered to Transport Canada. And if you take a look at that, Transport Canada registered for manned aircraft 2021, just over 37,000. So almost twice the population, or twice as manned aviation. If you look at just BC and Alberta, I mean, just saturated in there, we're probably 1,500 and growing as small, medium business drone operators. So you got the number of basic pilots operated, certificates issued, almost 68,000. And for the number of advanced, going beyond visual line of sight, almost 7,500 people. And this is just going to keep on extending and keep on growing. So Transport Canada, when you're looking at flying beyond visual line of sight, there's some pretty stringent requirements, and look at two main groups, the training and documentation. For training, you're going to need to get your advanced certification to fly that drone. Maintainers, if it's something over 25 kilogram, will typically probably have some manufacturer unique training as well. And the documentation, that's the key thing here for flying. For beyond visual line of sight, you're going to need your flight operator's manual, a maintenance manual, training manuals, and all this could be combined into one manual. Site surveys, where you're going to be looking at local terrain, nearby airports where you're going to be flying, obstacles such as power lines, buildings, structures, no-fly zones, etc. The normal standard operating procedures, what are you going to do with your team, who's assigned to specific positions, and how are you going to operate that drone pre, during, and post. And then your CONOPS, that's basically an overview of everything you're going to do. Safety plans, so what safety mechanisms do you have in place? Emergency procedures, such as if you lose your C2 link, what are you going to do to recover that? And then insurance. There's liability, of course, if anything happens when you're operating, you need to have some liability insurance to cover for that operation. So Transport Canada, specifically, when they look at anything that's flying for beyond visual line of sight criteria, they break it into what's called an operational risk assessment, or an ORA, for flying beyond visual line of sight. So this ORA is to safely create and evaluate and conduct UAS BVLOS operation. So they're going to go two classes of operation. They're going to specifically look at the ground risk class and the air risk class, which is the GRC or the ARC. And the UAS operator provides a multitude of operational safety objectives or OSOs for Transport Canada. Technically, there's 24 of them there. And overall, then, when you look at your GRC and your ARC and the OSO applications, you're going to be looking at a specific risk score for that operation. So it's going to determine, depending on what zones you're flying in, what terrain you're going to be in, is it controlled air, is it uncontrolled airspace, what's your altitudes, et cetera, et cetera. And this SAIL, which is your specific assurance and integrity level, SAIL 1 to SAIL 5, it's not linear. The higher number you go up, dramatically can increase the risk. When you're looking at kinetic energy, like your GRC, or what's flying nearby. Is there other manned aviation, for example, flying in those areas? So here's a picture here of your ground and air risk model. So here you are, your drone flying there. So you've got operational volume, which would be this flight geography. Then you want to look at contingency volume. So what happens if you fly outside of that flight geography? Then you look at your emergency procedure. So your ground buffer, you got adjacent, like urban center over here. What's going to happen in kinetic energy if that thing was to crash? And what are your emergency procedures? And then also on your air risk model, or your ARC, adjacent airspace. So your emergency procedures, what are you going to do for air traffic control if something is like a flyaway? All those have to be considered. This one here is air risk class. And for the air risk class, they break it up to ARCA, all the way up to ARCD. And you can see ARCA is green, meaning that is the lightest, and ARCD is red, meaning that is just about, one of the hardest, if not feasibly possible to get at this stage of Transport Canada, as far as to flight beyond visual line of sight. So your ARC-A is, and we'll get into this more definition, is atypical airspace. So you don't need too much for a SAIL environment there. ARC-B, this is below the 400 feet within the Class G airspace, is not inside the airport, airdrome, or the helipad environments. And again, the mitigation risks are a lot lower to be able to fly in that airspace. The majority of you folks, I envision, are going to be what we call this ARC-B classification. ARC-C, now you're going to be flying, it could be like a my class F airspace for drone activity. And then also, looking at this one, ARC-C, if you're going to be flying below 400 feet within an airport environment. And specifically, these are the regional airports, not the international airports, as they call that. E or G would be the rural airports that are uncontrolled, no traffic control. And F is restricted airspace there. When you get into the C over here as well, that's above 400 feet. D, now you're looking at Edmonton, Vancouver International Airports as an example. These ones are really hard. The sail level up there dramatically. No one has, without specific criteria, been able to fly in international airports. But again, majority of your flying activity is probably going to be predominantly an Arc B and possibly this Arc C scenario in the uncontrolled airspace. So the more accessible areas to fly here in Canada, well, you got the isolated areas outside of those concentrated population centers, dispersed as they define it, low densities of less than 0.1 persons per square kilometer. Atypical airspace could be the northern domestic airspace, that's the high Arctic, at or below 400 feet above ground level, outside those airports within that region. Restricted airspace, such as the foremost UES test range, with permission. That's this, you've got an SFOC, and you got permission for me to be able to fly in there. 100 feet or and then uncontrolled airspace class D with no air traffic control and outside an air environment. So here is your northern domestic airspace, or NDA. And again, you know, I've lived up there, not much population. So as long as you're away from any urban centers, villages, airports and that, you know, that geospatial population density is very low. Also, BVLOS at 400 feet, something such as this oil and gas pipeline inspection, you'd be able to fly. Now, again, as we get more into it, you're also going to have to look at what they call a detect and avoid system. It has to be in place, and it requires a DAA solution of at least 70% detection. So one of the things for a solution, and this is one of the quicker per se authorizations you can get from Transport Canada, it's called a short range beyond visual line of sight, or an SR BVLOS, SFOC with human detect and avoid. And you have a criteria, you got to be away from populated areas. You have to be at least 2 nautical miles. You got to be away from population density, so it can only be about 5 persons per square kilometer. You got to fly at or below 400 feet. And the maximum distance between your PIC and the RPA is going to be 4 nautical miles. And what you can do here is they use, for human DAA, is visual observers. So the VO can be 2 nautical miles away from the PIC. And so instead of EVLOS, where they would have to be within sight for the handover, now they allow the operator to have a VO strategically located, so that extends the range. So 2 nautical mile, then for roughly argument's sake, they have a 2 nautical mile airspace coverage that they're looking here. And the key thing, they got to be able to communicate, whether it be cell phone, by radio, effectively with that PIC. So this one here, again, in that type of criteria, you'd be able to get an SR BVLOS, that uncontrolled airspace. And that would be a good practice to get started with. Now, if you're going to go beyond or a higher level of sail, as I referred to them earlier on, then you, or different controlled airspace, now you're going to be looking at a lot more stringent controls and mitigations. But this one here, as I mentioned, as long as you got all that other documentation in place, as I mentioned earlier, would be a lot easier for you to get approval from Transport Canada. And you don't need to be using the test range for these applications. So now they have a tool out here. It's called the Drone Site Selection Tool. And this particular tool allows, if you look at it, you can just Google Drone Site Selection Tool there, it'll come up for Canada. And every one of these colors means something in that region. So I've got like a western part of BC out here, southwestern. So for example, if you look at Princeton, BC, and you click on that one, well, they call that airspace as Class E. So that is a air traffic controlled airspace up to 3,000 feet. And it says here, basic RPAS operations are not permitted within that zone indicated by the red filled shape. Another place here, well, Pacific National Rim, National Reserve of Canada, you can't fly any basic drone operations without permission in any national park. And let's take a look at it as an example. You're going to try to group a mission out here. We'll say you're going to go through the BC Energy Natural Gas Pipeline. And I've got it, say, for argument's sake, just north of Hope, going through Abbotsford, Vancouver, Fort Coquitlam, and then up through Iron Bay. So if you look at, there's different aspects here along the way. You've got an aerodrome over here, and that's called an ARC-C. That's in Class G uncontrolled. So about a 5 nautical mile radius, specific, you won't be able to fly in there for visual line of sight. So you need a SFOC if you're going to be flying in there. Then, so this little segment here, just before Harrison Hot Springs, or Agassiz, I guess, now you're looking at a population that's just before your urban population. So you could fly with EVLOS, an example, or short range BVLOS in this little segment of about 5 nautical miles, let's say, for argument's sake. Then you go over here. Now you have another little airport here, uncontrolled Class G. And then another one here. This is the Abbotsford. They call this an international airport. And this one's Class C, so it's red. So it's got a higher sail. You're going to be like a sail 4 to be able to fly into that airspace there. It's going to be very difficult, or pardon me, a sail 5, I should say. Now you look here, this is the urban center. So again, flying over that is going to be very difficult. Flying over people, that all has to be approved through Transport Canada. And same as this segment. This is all urban center through the Greater Metro Vancouver. Then just when you get about north of Port Coquitlam, now the yellow, that's, again, you could use VLOS, EVLOS, or those short-range BVLOS to fly this uncontrolled Class G airspace. And as you go further north, and that's pretty much, again, open terrain there for you. So again, it's all part of that planning perspective every stage along the way. So solutions to perform BVLOS missions. So your GRC, your ground risk criteria, and your air risk criteria mitigations. So you have to be able to mitigate that by meeting the robustness containment criteria, employing such DAA functions like your VOs or ADS-B, or you could have different sensors with the radar, return to home geofencing. All that has to be built in. And then you've got your built-in redundancy in the system as required, complying with the operator or manufacturer declaration. Your OSOs, your objective safety have to be verified. Training, operational, technical, and environmental testing performed. Your DAA system has to be tested. And you have to have a safe recovery throughout that. And then the third-party validation. A lot of these different OSOs are going to require third-party validation. So we have, through that, an airworthiness program, and you verify test application at a test range. So this one here just shows airspace situational awareness. So you can look at here, you've got your ground control, and you have different sensors applied here. For example, you could have some kind of a radar sensors out here. Here's your drone flying out here, and you've got adjacent airspace. So they have to be aware in that contingency volume of what's out there for awareness, and what are your ways of DAA, detection and avoidance, and communication to be able to control that at any given time your aircraft. This one here, solutions. So they show other solutions for your DAA geofencing area out here. You also got unmanned traffic monitoring, and your communication is the key thing here. So again, every little aspect of your airspace has to be considered of where you're flying. So BVLOS innovation capabilities. We have within our organization UAS and RPAS expertise, over 60 years of technical and engineering background to support RPAS. And also we have regulatory compliance, and we have a robust airworthiness program that we've taken through with other projects. And at the foremost UAS test range, we're able to test and validate our RPAS airworthiness program. So the airworthiness aspect is three things. You got your technical airworthiness, your operational, and your regulatory. Technical includes things such as your design, specifications, your flight manual, your DA systems, your managing aspects. Operational awareness includes things such as your test procedures, your standards, operator competency, etc. And your regulatory includes things that Transport Canada requires, such as your NOTAM, your SFOC, and your ORA for all your mitigations. So looking at the airspace here for foremost UAS test range, we can support, with fixed air wing, we have a 3,000 by 75 foot asphalt runway. We have over 700 square nautical miles or 2,400 square kilometers of contiguous airspace, over 300 visual flight rule days, and average mean rainfall is about 200 millimeters, and our average speed is 7.8 knots. So with the layout of the land, we've got crops, grassland, water features, livestock, wildlife, oil, gas structure, power distribution lines, road network, and rail lines. And with the geospatial out here and our infrastructure, with our hangar and other support, it's a wonderful place here. We don't have a lot of manned aviation that flies out here. So we're able to control the airspace, or at least communicate in real time to the local stakeholders whenever we have activities, and a notice to airmen is activated to activate our Class F restricted airspace. And here you can see three different regions of our Class F airspace, 234, that's up to 10,000 feet from surface level. And 235, that one is 4,000 to 10,000 feet. So mean sea level about 2,900 feet. So we're actually, when you look at 4,000, 2,900, that's about 1,100. So there's actual local flyers that fly below this particular region when we activate it. And what that gives us here is about 80 kilometers of airspace to fly. And some of the big flyers, we could activate the third layer, 10,000 up to 18,000 feet. And now you can fly not only duration, but also altitude. And so why BVLOS Innovation Center? Again, I can't specify enough, airworthiness, transcending your operation to BVLOS operations, developing an RPAS airworthiness program, and Project Sky Census is a big project we're involved in. Airworthiness program is very comprehensive, risk-based, drones, to process for third-party accreditation and for the RPAS operation. And so basically we can provide the manufacturer, the drone operator, with an exit strategy. So if you want to fly BVLOS outside of controlled area and beyond just those simple or simpler operations of that remote, uncontrolled Class G airspace where you're getting into other environments, then we can get you to those sale criteria, check marks out, so that you can fly, and then of course your return on investment or ROI would be extended to extended ranges that you're able to accomplish. So why perform BVLOS missions with BVLOS Innovation at foremost UAS test range? Number one, drone safety. Safety of people and property in the air, and people and property on the ground. We got controlled airspace, as I mentioned, as UAVs fly in this Class F restricted airspace controlled by us, and allows the client to test and perform all their BVLOS criteria at the lower operational readiness assessment. Safety is achieved by our technology, regulations, adherence to regulations, and to training. And then testing that RPAS system at the foremost UAS test range. So again, you look at it, it's policies, specifications, design, operation training, test and eval, verification, and certifications throughout the spectrum of airspace. Here's just a picture of flight testing here at the foremost UES test range. A lot of different clients and operators that we've had out here through the years. And that wraps up our presentation. And again, it's a real pleasure to be able to talk in front of all of you. And I wish the best for your success and your drone endeavors and operation. And if any questions, I've got up here my phone number, email address. Please feel free to call. And once again, thank you very much. And I really appreciate your time and look forward to perhaps seeing you folks out here in the near future. Take care.